7th grade lesson 8.2 is geometric drawings, and they're really more focused here on triangles and a little bit of information about triangles. And they are using protractors. So I'm going to do a quick review of the use of protractors for you. And if you don't have a protractor handy, that's okay if you have a cell phone. I found the app called in the App Store called Protractors. The icon for it looks like this. And I did see some other protractor apps in there too. This was the first one I did. It was free. So I downloaded it. And when you use it, it just shows a protractor and it is see-through through your camera. And so you can kind of apply it on top of the angle that you're looking at. It'll look like this. So I just adjusted my camera so that the center bottom of my protractor was at the vertex of my angle. So in this case, I would be trying to measure this angle right here. And then I would look to see, oh, and I should have lined this up better. This line should be lined up on this line right there. So just quick, so it looks like that on that app. So quick review on using a protractor. Notice you have it counting from 0 to 180, a straight line going this way, but you also have it counting from 0 to 180 going the other direction. That's so that if you have an angle facing this direction, like this one is, you can start at 0 and measure it. Or if I were to move my protractor over and I had a, let's use red, let's say I had an angle going this direction, and I wanted to measure it going the way that the straight ray is pointing, then I would start at 0 going this way. So you start at 0 based on which direction the ray that's on the bottom is pointing. In this case, if the ray is pointing this way, you start at 0 and then you go back depending on where this one is at. So this one would be starting at 0. And it points up to, so I'm on this row, it points up to 100. So that would be a 100-degree angle right here. This other one that you can see going this direction, if I had lined it up correctly, and by now you probably remember that a straight angle that's lying flat is 180 degrees. So if one side was 100 degrees, this one should be 80 degrees, right? So this ray is pointing this direction. So I'm using the 0 over here on this side and moving up, and there it is at 80 degrees. So that's the refresher on using your protractor. This lesson is going to talk to us about, they just really want you to name, is this a unique angle? Are there more than one angles, or is it no angle? And so it seems confusing at first because they don't ever really, well, they explain it, but I didn't catch it well enough, so it took me a while to kind of understand what they're after. So here's what they mean by that. Unique angle would mean there's only one shape and size of the angle that it can be. So we'll just put only one. And more than one obviously means that you could have several of different sizes. And maybe even different shapes, possibly. Actually, I'm not sure. Anyways, you could have different sizes. And then no triangle would mean you can't make a triangle out of that. So just so that you understand the pieces involved in this will, and once you understand this, it makes this lesson easy because pretty much all they're asking you is unique triangle, more than one triangle, or no triangle, and you just have to look at the data they provided to you and determine that. So a unique triangle, so let's start with the more than one, actually. Let's start with the more than one triangle. So by now you probably remember, let me just change that color so it doesn't bleed in with the other information I just gave you. By now you probably remember that all of the angles inside of a triangle always add up to 90 degrees. Or I'm sorry, 180 degrees. So let's say this one is 90 degrees, 30 degrees, and 60 degrees, right? I can have that same triangle with the same angles and have it be bigger, and it will still have the same angles. And I could have it even be bigger, and it will still have the same angles. The angles don't change. If I put a protractor on those angles, that doesn't change. But I have 3 different triangles here, right? 3 different sizes. So that would be more than one. So if they just gave me angle measures, I can have all kinds of triangles of different sizes. So if all I have are angle measures, more than one is what my answer would be. Now, if they added to that a length, let's say that's 2 inches long, suddenly now to keep these matched and have this be a specific length, now I'm pretty much trapped to only being able to have one size shape of triangle. So that would be unique. So as soon as they put a length on one of the sides, they've trapped me into just one type, one size. Okay, so if I just have angles, more than one, I can have all kinds of sizes. If I have angles and I have a length, then I'm trapped. Basically, if I have a length, I'm kind of trapped into one size. Okay, so that would be unique. Finally, I'll go to a different slide on this one to explain the no triangle piece. Let's say I have a triangle that has a base of 8 inches on its long side, and then the 2 shorter sides, one is 2 inches and one is 3 inches. I can't get these to reach. And if you kind of imagine if you folded these down, and I folded, I'm going to choose for this line, I'm going to fold it down. I'll choose red to bring it in. 2 inches in, and I'll use blue to represent this line here. 3 inches in. Let's say I folded it down. 2 plus 3 is 5, right? That's not going to make 8. I'm going to be shy there. I'm going to be short. I have to have at least as much as 8 inches when you add these 2 sides together in order to build a triangle. And it can't even be equal to 8, because if it was equal to 8, then they're just going to barely touch, so there'll just be a line on top of the line. It has to be more than this larger one. So when you look at a triangle, the longest side, let's say this is 12, is your sum, and your, that would be more than that. I'm just going to go with a 6, I think. And your 2 shorter sides, right? These are smaller numbers than this one. So this is my longest side. My 2 shorter sides, when I add them together, they need to be not equal to, but they need to be larger than 12, the bigger side. So the short plus the short has to be larger than the long line, or else it can't build a triangle. It just kind of, if you fold it over, it does this sort of a thing, right? So it has to be larger than. Can't even be equal to. I can't put the little line under here saying equal to, because if let's say this was a 3, let's draw this again, because I don't think it'll let me erase. Let's go back to this original one. But let's say instead I had 3 here and 5 here. 3 plus 5 is 8, right? Well, they barely reach, right? And so I can't lift it. I would need more length there. So it can't be equal. 8 plus, oh, sorry, that should have been a 5. My bad. 5. 5 plus 3 is 8. You can't lift it. So 5 plus 3 is 8 wouldn't work. If this one was a little bigger or this one was a little bigger, then I can start to lift it a little bit, and then I can call it a triangle. But right now, that's not going to work. They're not going to touch. This isn't going to work either. 5 plus 3 is 8. They equal each other. You're just going to have another line. It doesn't have enough room. It doesn't have enough length to lift it. So short side plus short side has to be larger than the long side. So you might see some questions in there that says, you have a side length of 6 centimeters, a side length of 12 centimeters, and a side length of 7 centimeters. What kind of triangle are you going to get? Well, okay, let me check. This is the longest side, and 6 plus 7, the 2 shorter sides, must be bigger than that. 7, 8, 9, 10, 11, 12, 13 is greater than 7. And because these side lengths are very specific, I can only have one of that size, so it must be a unique triangle. There's only one of that size, and it can be a triangle because this is true. If they had given me 12 centimeter, 4 centimeter, and 5 centimeter instead, then I take my biggest side, 12, and my two shortest sides, 4 plus 5, need to be bigger. 4 plus 5 is 9. That is not bigger than 12. So my answer on that one would be no triangle. So if angles are all the same and they didn't specify a side length, more than one triangle. They can be all kinds of different sizes. If side lengths are there, then you're limited to one triangle, if it can be a triangle at all. The way it can't be a triangle is if your two short sides added together are not bigger than your long side. So those are the pieces of information you're looking for in this lesson, and that's how the whole thing plays out. So that so use that information. Hopefully that clarifies what they're asking for. They only ask a few questions on it, and then they move us on to the next lesson. So go ahead and give it a shot. I think you will do well.